AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 5, Classification Analysis. Chapter 5, Section 4, Decision Trees. A decision tree is another kind of classification algorithm, and it works in a very visual, step-by-step way. You can think of it as a flowchart that splits the data into smaller and smaller groups based on questions about the data, like, is age greater than 50? Or, does this person own a dog? Each of those splits is a decision, and together they form the branches of the tree. By the end of this section, you'll be able to describe what a decision tree is, identify its main parts, understand how it decides where to split, and recognize when it becomes too complex. You'll also learn how to check how well your tree performs using a confusion matrix. What is a decision tree? A decision tree starts with your full dataset at the top. This is called the root node. The algorithm looks for the best way to divide the data so that the resulting groups are as pure as possible. At each step, it splits the data based on the variable that best separates the categories. Those splits form branches, and the final outcomes, the predicted classes, appear at the leaf nodes at the bottom of the tree. Advantages and disadvantages. Decision trees have several advantages. They're easy to understand and visualize. You can literally follow the path down the branches to see how a prediction was made. They work with both numerical and categorical data, and they don't require much pre-processing. But there are some downsides too. For very large datasets, trees can become computationally heavy. And if the tree grows too deep or too specific, it can overfit, meaning it memorizes the training data instead of learning general patterns. How decision trees work. The process starts at the root with all your data. The algorithm asks, which variable and which cutoff best separates the classes? It makes that split, creating two new branches. Then it repeats the process for each branch. This is called recursive splitting, until the groups are as pure as possible or until we stop it. The leaves at the bottom represent the model's final predictions, for example, yes or no, adult or child. Splitting and impurity. Each split must be mutually exclusive. For example, one group might be age less than 10, and the other would be age 10 or greater. The goal is to make each split reduce impurity. Impurity just means the amount of mixing between classes in a group. We want each group to contain mostly one type of label. A common way to measure impurity is with something called the Gini index. At each step, the algorithm chooses the split that most reduces impurity, which helps improve classification accuracy. Example: age split for senior citizens. Imagine a dataset with people of different ages, labeled as senior citizen or not senior citizen. The decision tree might find that splitting at age 51 works best. People over 51 are more likely to be seniors, and people under 51 are not. The leaf nodes at the bottom show how many seniors and non-seniors fall into each group. Example: predicting car driving by age and dog ownership. Let's take another. If we're predicting whether someone can drive a car, the first split might be based on age. If age is 15 or below, the model predicts no driver's license. For older individuals, the model might look at another variable, like whether they own a dog, though that variable might not be as informative. The final leaf node showed the predicted answers for each path through the tree. Overfitting and pruning. A tree that fits the training data too perfectly is said to be overfitting. It may perform very well on the data it was trained on, but poorly on new data. Signs of overfitting include leaves that contain only one or two samples. To fix that, we can prune the tree, meaning we remove unnecessary branches to simplify it. We can also set a minimum sample size per leaf so the tree doesn't grow too specific. Simpler trees usually generalize better and make more reliable predictions. Evaluating decision trees. Once we build a decision tree, we need to test how well it performs. We do this by comparing its predictions to the actual labels using a confusion matrix. That shows how many cases were correctly and incorrectly classified. It's also important to test the model on new or unseen data to make sure it generalizes well. If performance drops sharply on new data, that's another sign of overfitting. Summary: to sum up, always split your data into training and testing sets to check performance. Use confusion matrices to compare different tree versions. And remember, a simpler tree often outperforms an overly complex one. Decision trees are a powerful tool because they're intuitive and easy to explain, making them a great starting point for understanding how classification models work.